to say, thou shalt not use more air. If I do that way, then I can take a parallel line through the new point, and I can calculate out that difference, how much more it costs. Second way of doing it would be to say, aha, thou shalt get to this new point, and I should make you go there by choosing the prices to do it. So now I need to find a set of prices. Well, we draw a tangent line. If P2 is 1, right, then the slope of this line is exactly minus P1. So if I chose the price P1 correctly, then they would choose that point. You can think of it as a tax if you like, because you look at this one. This has P1, we'll call it 0 with no tax. And this new P1 tax, right, is definitionally whatever the tax is. So just add to the price until I get them to do the right thing. When you look at these two ways of doing business, the taxes always cost more. Right? So here's a flat line through the point. That's the original prices. Here's the tax tangent to the point. Has a higher P, it's a higher slope. It's got to intersect higher up here. The intersection up here is literally I over P2. I chose P2 to be 1. So the cost is much higher. Tax. There's only one quantity. I'm sorry. Original quantity, original price. Yeah. One to go here because they're destroying the planet. Yeah. Two ways. One, right? And that way is just you must go there, leave prices the same. And if you draw a line with the same slope as the original, here it is, and you read off how far it is up here, that's the cost associated with the line, right? Second way is take the prices that they pay for clean air and just start wedging them upwards until I get a price high enough so it's just tangent here. Now they'll do this voluntarily. And the cost is going to be the height of this intersection. Both lines are going through the same point. The original one has a lower slope, at least in absolute value. Yeah? And so this one's going to come in much higher. The geometry assures you of that. But you just think about it for a minute. You're doing the same thing either way. You're buying the same bundle. One way you're buying it at a high price. That's got to cost more. Right? There's nothing magical about it.
So up here says the cost curve. Is the cost curve just like you know what the price of what the cost would be for those two different topics?
No. I've done the pollution first. You want to derive a cost curve, we'll do that in a second. Yes. But logically, it's got to be. You're buying the same bundle of air and other stuff. Here, you're buying it at high price for the air. Here, you're buying it at low price for the air. But you're buying the same thing. So when you buy it at high price, it's got to be more expensive. Yeah, they're taxing clean air until you buy little enough of it. Right. Okay. So one is the classic affluent standard, in this case for unit output, and the other is the classic tax for pollution. And the tax for pollution costs more. And then you can take it back this way. Original, standard. And this is the polluter pays principle. You make them pay for it, their costs will be higher. If their costs are higher, then the quantity will be lower. So we get a twofer if we do this right. From an economist's point of view, doing this right is I make them pay for clean air. As soon as I do that, they will get the correct way of building their car. The correct way will get built into the cost of cars and will deter you from buying cars. And so we get both going on. Whereas if I do it the other way, I don't get enough deterrence to buy too many cars. They make the cars right, but you don't fully pay for it. Yeah? You're not paying for the air you used. Here you pay for every bit of air you use, every bit. That's what drives the cost up.
So the one on the left is the tax, or another one on the left is different.
This is tax. Okay? I've jacked up the price so it's tangent. This is standard. I told you what to do. But I don't charge you for the air you use. So you'll make your cars responsibly, but your cars still make NOx, and I like to have the NOx for free. And you pass the free NOx on to the consumers. Right? That's what's going on here. This is a consumer with free NOx. This is a consumer paying for his NOx. Because it's free, he buys too much of it. Buys less than he buys if he was unregulated, but he buys too much relative to having to pay for it. If you really want to turn off the pollution problem, you really have to go the whole hog. You got to make the producers pay, and the producers will pass some or all of that on to the consumers, and then the consumers will pay it, and they will buy less. It's not very politically attractive, is it? When you go out there and say, we're going to clean up the air, and you're going to pay for every penny of it. No, okay. You don't want to say that. Did you see the Berkeley soda stuff? Did you see the big statement, we'll tax the producers and therefore you won't pay? It's a weird statement. But that's what they said. Because if they said, oh, in economics 101, we know that you'll pay part and the producers will pay part. We don't really know quite how the curves will work. So we're really not sure whether they're bent this way or that way. But you'll be paying some of it. That's not very good politically, is it? So that's why. It tells you exactly why the polluter pays principle is not attractive. If you do this, then you really will charge the consumers more. And they really will be angry with you. So this has been the feasible compromise. All right, so you wanted to know what cost curve was. Cost curve is Yeah, okay. These are 2 points on a cost curve. Yeah, chosen Q low, Q high, found the tangencies with some set of prices, set B2 equal to 1. So now the cost of this bundle is the same as the cost of that bundle, is the same as this distance. Yeah. And so that's cost low, and the cost high. It's 2 points on a cost curve. Let me look at what else we got. I make life easy, by the way. In my examples, equal pollution lines, isoplats are just up and down. Yep. Yeah, isoplats is an equal pollution line. You'll find it in the text. But I use examples where it's the same. You look at the latest examples in the text, it's not. They're a complicated curve in water nitrogen space. In general, they're a complicated curve. I just want to make sure we got it all. Technology-based effluent standard. Can someone give me a quick definition? How do people set standards? Yeah. Come backwards to the policy arena. What do I have to do to make them comply? No, I get a big placard that shows a 6-speed transmission. And I hold it up in front of the board, airboard, and I say, 6-speed transmission, make pollution go down. So this is a technology. So I demonstrate a technology to make pollution go down. Then I say, okay, 6-speed makes pollution go down, carbon, by 12%. That's the showing I make. The board then says, well, therefore, thou shalt make cars 12% more efficient. Any way like you please. You can use this, you can use whatever you want. Yep, that's the statement. The diagram that goes with it is this diagram. It's just a standard per car. Less air per car. If you want to carry it out further, you'd say my 6-speed transmission might be a point up here, above the isoquant. Because I don't know all the ways of doing it, and the firm will spend a lot of money to figure out how to do it right. So their point will be lower down on their isoquant and cheaper. That'd be the whole story. Okay, we're down to marginal cost of abatement. How much will it cost to get rid of 1 more unit of pollution? The marginal cost of abatement. How much is it worth to get rid of 1 more unit of pollution? Marginal benefit of abatement. Best point. Argument as usual. Choose a different point. What would happen if I went this way? Well, how much would I lose in the way of benefits? The area under the marginal benefit curve. How much would I gain in terms of avoided costs? Area under the marginal cost curve, which is bigger. So could I get it go this way? Make the same argument on the other side. Remember, we're using here is costs of abatement is right? That's the important thing that we're able to do. You say, suppose I abate 1 unit less. How much money do I save? Marginal cost of abatement. How much benefits do I lose? Marginal benefits. MCA bigger than MCB. Great idea. Abate 1 unit less. So we get the year. That's the optimal abatement. Next problem. Get out of there. Two firms, both can abate. How much should each one abate? So their marginal costs are the same. Why? You did this in the trading game, because otherwise you could make more money. If you were here, you'd make more money by going this way. Mr. A would abate less. Now remember, in these diagrams, you're reading Mr. B going in this direction, Mr. A going in that direction. So the width of this box is the total abatement. It's just a question of how I break it up between the two. So a point like this means Mr. A abates this much, Mr. B abates that much. All I'm doing is I'm moving this over until I get here. That's the whole idea of cap and trade. This is the size of the cap. But I don't really know who should be doing the abatement. But if I let them trade the certificates, they'll trade them around to get minimum cost, just like you did. Actually works. They will. You can do some other things with this. You can ask, what else can you ask with them? Oh, I guess we can find ways of making them do the right thing. So here's marginal cost of abatement. Suppose I want them to abate this much. I happen to know it's where marginal benefit comes through. I mean, how could you do it? One is you just tell them to do it. That would work. Two is you could tell them, here's the total amount. Go figure it out if you already knew the total amount. Another possibility, the price on it. That would work. We'll pay you for each unit of abatement. Then you'd abate up to here. That's pretty expensive. So how about taxing them for their pollution? You do that. What do they do? Yeah, but how much? You got a choice. If you pollute, you pay T. If you abate, you pay FCA. Yeah, because if it's cheaper, here's abate, right? We're going in this direction. If it's cheaper to abate, you'll do that. And so you'll abate. And then, above that, what do? You don't abate, you pay, if you had to. Or you stop. You stop. Yeah. Can you make an argument for why the quantity of a pure public good, you won't get the right quantity for a pure public good in the market? Simple example, simple as you can devise. The market doesn't do it. The market won't give you the right quantity to make of a pure public good. It will undersupply it. So what's a pure public good? What properties does it have? No, what was it? Not excludable and not rival. So just think of something that costs a fixed amount to make. We're working for simple. It costs $2 to make. And let's say it's worth $1.50 to each of you. Would any of you buy it? So what would the market produce? What would happen if any two of you got together and had tea and talked about it? Right? Two of you would be willing to pay $3. So would you buy a unit? Okay, so you got your simple example. That's all you need to show that the free market underprovides public goods. What does Coase have to say? Coase is actually a difficult article to read. Haven't you read any of it? I'm just curious. Oh, that's pretty good. Okay. That's more than 0. But you should read a little of it. It's like this truly classic article. So it's worth the first whatever number of pages until you fall asleep, your head hurts. Which happened. The head hurt, fell asleep. I'm not sure. Here's anesthetized by it. You have to try reading it. It's really worth it. Coase simply argued that there can be trading. And when there is trading, it won't really matter who you give the rights to. So you think of the trading game you did. If you did your trading game right, what point did you stop? You had a value for the certificates. The other person had a value. Were those two values equal? When you stopped, you did it right. Yep. Did it matter who had the certificates to begin with? No. So that's Coase where trading is inexpensive. But Coase also covered the case where trading is expensive. And obviously, you'd like to be here. But suppose it costs too much to trade. Well, two focal points are here and here. What happens if you get pinned here? The regulator says, in this case, all the abatement will be done by B. A shall do nothing. You can figure out the cost of that. And let me flatten this out. What about the opposite? It shall all be done, all the abatement should be done by this guy. What are the costs of the area under his curve? So now you come to the question, which of those two curves has a bigger area under it? You can't trade. You can't get to the right answer. But is it better to make this guy do all the work or that guy do all the work? And in law, a very controversial answer is, actually due to Judge Learned Hand and taken up by Judge Posner, was if the law didn't otherwise say what we should do, we're going to make the guy do it who has the lesser cost to do it. Because that will give the better social outcome. Your private outcome would suck because you have to do it all. But socially, there would be less total costs. And that's the sense in which Coase is used by what you think of as the right. Whereas when we go and say we should have tradable pollution permits, for some reason they think we're the left. I don't know why. Maybe because it has to do with making pollution less. So Coase's ideas cut both ways and very sharply so. Oh, okay. So we have very little left here. Can somebody, without reading it, give me a description of how the Clean Air Act works, or at least a piece of it? Everybody will be able to do it in 2 weeks' time, right? So it's got a lot of parts, but you want to try it? No. Anyone want to try? So the basic idea is that it's envisioned as a public health act, not as an economics act, not as anything else. It's envisioned as a public health act. So the U.S. EPA will set standards for the air based on public health. Then it will go to the states and say, here is the standard for your state. You are to regulate stationary sources, basically any smokestack. And you're to make those regulations in such a way that the ambient air quality standards will be met. That's your problem, Mr. State. Second piece is U.S. EPA itself, and California can also do this, but no one else,